This is a lecture 6A talking about characterizing data. So this section is going to be all about talking about the distribution of our variables as well as measures of center. And basically, we're going to use numbers to tell us how spread our data is from beginning to end or from specific points, as well as using a single number to represent maybe the average value that we can expect. The measures of center that we will talk about in any distribution are the mean, or commonly thought of as the average, which is where you take all of the values you got, add them together, divide by however many values you had. The median, which is the middle value when the data is sorted from smallest to biggest. Or do note, if you end up with 2 in the middle, we're going to find the halfway point between those two values. And the last one is the mode, or the most common value of the group. These terms should be common for you. Most people have heard of them before, so hopefully this is not anything new to you. We're going to work through an example here. We have 8 grocery stores that sell the PR energy bar for the following prices: $9, $29, $29, $35, $39, $49, $59, and $79. We want to find the mean, the median, and the mode. First up is the mean. So what you're going to do is you're going to add every single one of these numbers together. You're going to get that total. So make sure you hit equals, get your total, and then divide that sum by 8 to get your average price of $1.41. To find the median, we first have to put them in ascending order from smallest to biggest, which the data already was. And then what we're going to do is we're going to work to the middle. So the way that I usually do that is I cross off one on each side, cross off here, and you'll see they've got those grouped and these grouped. And I'm left with 2 in the middle. Sometimes you're left with 2 in the middle. Sometimes you're left with just a single value here, and that's your middle. Well, when you're left with 2, what we have to do is we have to find the middle of the middle. So anytime there is an even number of data, you're going to have 2 numbers left in the middle. So we're going to find their middle. We do that by adding the 2 values together and then dividing by 2. So $1.37 is going to be the median. And then when it comes to mode, you just have to look at all of the numbers, which one was written the most. And that was $1.29 is the mode.
What I'm going to do now is show you how we could do this in StatCrunch. We are going to have to type all of the values into a column. So bear with me while I do that. 8.6. All right. We are going to hit Stat, Summary Stats, and Columns. What I'm going to do is it's going to give me all of these together as long as I follow these steps, all of them together. I'll follow all of my steps in the order I show you. Click your variable. It should pop over here. Now, it does not automatically select mode. So if we wanted to do mode here, it says select more than one with either shift click or control click. Shift click will highlight everything, which we don't need to add. So I'm going to do control click and also add mode to my list. So you'll see up here, I already have mean, median, and I want to add mode. So I hit control and then I click compute. Now there's more values here that we're going to talk about in a little bit, but for right now, we just want the mean, the median, and the mode, which is going to be on the end here. So this is 10 people's body temperatures. The average body temperature was 98.44. The median was 98.4, and the mode was 98.4. So all of these values really close together.
in that previous data set, all of our values were really close together. The mean, the median, and the mode were all about the same value, 98.4. Now, there are times, though, that when we look at data, all the values are not going to be close together. And we get something called an outlier. An outlier in our data set is going to be a value that is either really, really high or really, really low compared to the rest of your values. And what's going to happen is if you put that in your calculation for the mean, it is greatly going to impact your mean. It doesn't affect your median or your mode, but it does impact your mean. So let's talk about it here. Let's say we have the following contract offers, 0, 0, 0, 0, and $10 million. Well, if I look at this, clearly the mode is $0. It happens 4 times. The median, well, they're in order. So if I go cross off, 0's left in the middle. Average, mean, wants me to add them all together. So add all these together, I get 10 million. Divided by 2, the average is 2 million. So as you can see here, this one really, really high value pulled the mean up a lot higher than your mode and your median. So let's talk about the mean, median, mode a little more. The definition of the mean we talked about is add all of them, divide by how many there are, and commonly called the average. This will always be able to be calculated, but it is affected by outliers because the calculation uses all of the values. Advantages of it, everybody understands the average. Disadvantage, if there's outliers, it's not a very good representation. Median is going to be the middle number when we're put in order. It can sometimes be called an average. It will always exist, but it does not use all the numbers to be calculated. It's either the middle number or it uses the middle 2 to get calculated. Do outliers affect it? No, because if you have a really high outlier, it gets crossed off. If you have a really low outlier, it gets crossed off. So advantages, clearly this one's used when there are outliers. It's a good represent of the quote unquote average of your population. Mode is the most frequent value. It's not really called an average. This one may or may not exist. Sometimes we have a value that is clearly shown more than others. Sometimes there are 2 values that occur more frequently than the others. There are other times when nothing happens more than the other. Every single number is different, then you wouldn't have a mean. So we can have one mean, I could have one mode, I could have 2 modes, I can end up with no mode. So it doesn't always have to exist. Outliers don't really affect them because usually outliers are one really, really high or really, really low value. So that usually doesn't impact your mode. And this is really used to represent when we're talking about word data. So if you ask everybody what's your favorite sport, you would talk about your mode because you'd want to figure out which sport gets said the most. That's where mode is used more frequently. A track coach chooses 5 of her best runners to wear a heart rate monitor during a workout. In the middle of the workout, she reads the following heart rates: 130, 135, 140, 145, and 325. Which measure of center would be best to use in this situation, the mean or the median? Well, you should always ask yourself, are there outliers? Well, yes, this has an outlier. If you have an outlier, you should not use the mean and you should use the median. After a survey of assembly workers in regional high-tech companies, the news reports that these workers earn an average of $42 per hour. The workers at one large firm immediately request a pay raise, claiming that they work as hard as employees at other companies, but their average wage is only $36. Management rejects their request, telling them that they are overpaid compared to the regional average because their average wage is $48. Can both averages, in fact, be right? Let's explain. So the quick answer is yes, because when you use the word average, you don't know if the group is talking about the mean or the median. So the workers may use the median while the management is using the mean. So let's look at an example here and say we had 5 workers that were 36, 36, 36, 36, and 96. The median is 36 because if I were to cross off, 36 is in the middle. So the workers claimed an average of $36 using the median. However, if we calculate the mean and add all 5 of these values together, divided by 5, we get 48 as the average, but based on the mean. So depending on which average you are using, you can kind of argue more than one thing. So it's very important that you make sure you state which value you're actually working with. When we work with data in nature, measuring heights, weights, things like that, we generally get this shape up here, which is called a bell curve or a normal curve or a unimodal distribution. The values on the end are less likely to occur as the values in the middle, and then they gradually then trend back towards to very unlikely. There are other cases of data that you could have what's called bimodal. It looks like the data goes up and down and comes back up and down. 2 shapes that we can look at. There are a few more we're going to talk about in a minute. And if you recall, this looks like the histogram. So we've taken all of our data and created a histogram, and then we can determine our overall shape. Another thing we can see when we look at the graph then is it symmetric. Symmetric meaning that does the left look like the right? Because in a normal bell curve, we have a symmetric shape because the mean is equal to the median is equal to the mode. They all are the same value, which was just like that temperature data that we found. The mean, the median, and the mode were all 8.4. However, there are times when we work with data that it is not symmetric, and we'll see that on the next slide. That is called skew. We can have left skewed and right skewed, and it's usually the outliers that are impacting your data to make it skewed in one direction or the other. The way you know which way it is skewed is which side is longer. So I find the peak, and then this side is longer. So the left side compared to the right is longer. We have left skewed. In the case down here, here's my high point. The right side is longer. That's much more spread out. So we have right skewed data. And then you can see here just what happens with the mean, the median, and mode based off of those outliers and how they're impacting the graph. We can have 3 single peaked graphs. A single peak symmetric, a single peak left skewed, and a single peaked right skewed. So symmetric will be the same on both sides. Left will have a longer left side, and right will have a longer right side. Can we determine if these graphs would be symmetric, left skewed, or right skewed? We want to talk about the heights of 100 women, the number of books read during the school year by 5th graders, and the speeds of cars on a road where a visible patrol car is using a radar to detect speeders. So the first one is the distribution of the heights of 100 women. And we mentioned anytime we measure something like heights, we're going to follow that normal symmetric shape, because generally we're going to have a lot of people right in the middle, but you may have an extreme higher or shorter person on either side. Next example is the number of books read during the school year by fifth graders. So this one is probably going to be right skewed. So let's think about that. You're going to have those kids that are going to read a few books, right? 1, 2, maybe 3 books. But you're going to have those avid readers that are going to go out of the gate and I'm going to read 10 books in the year. And you're going to have that 1 or 2 student that's going to read a bunch of books and is going to pull that right side tail further. So this, we would say, would probably be right skewed. The last one was driver's speeds, knowing they can visibly see a patrol car using a radar speed detector. So usually if you see a cop with his radar gun sitting out, you slow down. So we're going to have a lot of people that slow down to the speed limit. But then you get those drivers that slow way too much. Okay, some drivers slow well below the speed limit. So you're going to have most people, let's say this is the speed limit. You're going to have majority of your people right here at the speed limit. You may have somebody stay a little bit above. Then you're going to have some people that see that cop and they like slam on the brakes and they are over here going super slow. So they're going to pull that graph to the left and we would have a left skewed relationship. So variation describes how widely the data values are spread about the center or from the peaks. So if we have a single peak and it looks like the data is really gathered together close here, there's not a lot of spread, so we would say not a lot of variation. The further apart these ends get from each other, the more spread or the higher the variation. So low variation, high variation, and we can talk about that for skewed, one peak as well as 2 peak data. The following histogram represents the time it takes between eruptions at Old Faithful. We can see here we have values everywhere from about 45 up to 110 minutes between eruptions. And it just asks us to draw a smooth curve that captures the important features and then classify the number of peaks we have, if there's any symmetry, skewness, or variation. So if we're going to draw, I'm just going to kind of follow about the middles of your boxes there and make a nice smooth curve. Clearly, we have 1, 2 peaks. This is not symmetric. I can't draw a line down the middle and show that I have the same thing on both sides. Skewness, I don't really know that we have skewness here. We have 2 peaks, so we can't really talk about skewness. Skewness we can talk about when we have 1 peak. And variation, we want to talk about the spread from beginning to end. How spread apart is it? And I would say this is pretty spread data. Like I said, we go from about 45 up to 110 minutes apart. That's a pretty big difference for times between eruptions. So how would you expect the symmetry and variation to differ between times in an Olympic marathon and the times in a New York marathon? Well, the Olympic marathon is going to pick the most elite athletes that we have. So all of their times are probably going to be really close to each other. So there's going to be a lot less spread or a lot less variation when it comes to the Olympic marathon. versus a New York Marathon where anybody can sign up to do it. You're going to have some really, really fast runners that maybe finish in 3 hours and some odd minutes. And then you're going to have the people where it takes 8 hours for them to finish the marathon. So the variation for the less trained or wider range of trained athletes is clearly going to have a larger variation than those with Olympic training ability. This is the end of this week. So you will have your Pearson homework for 5E and 6A, as well as your discussion board to complete. See you back next week.